So we are going to continue now with the second part. This part is more the operational part of life cycle thinking and life cycle assessment. With this short exercise that you are working on, it helped in understanding now how do we really put this into practice. And I think this, oh, it works? I think so. No. 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 Pero gracias. And the important thing is that once that you know now, for example, regarding the milk packaging, okay, we are going to, I don't know how, let me second. Okay. Okay, perfect. ¿Sí funciona? Super. Okay. So yeah, this is the operational part. With this exercise, we now with this exercise we got introduced into, well, now if I want to do a life cycle assessment, how do I start? Now you can see some difficulties in there. For example, well, I need to have previous information. How do I know how to take into consideration how many pounds or kilograms of what material? So it starts to be a little bit complicated, but I have some answers and some tips and tricks for that. But it all depends in why would you, what's the purpose of that life cycle assessment. So, well, we're just, again, just a little resume of what we were talking about in the other presentation, is now that we have already identified more or less what are the materials, what are the inputs, what are the outputs in each one of the phases, what we have to consider in the raw material extraction, etc. Now that we have more or less an idea of everything that is related in our, or everything included in our life cycle, in all the phases, it all starts with considering why and how and what. For example, we right now we started with the different packages of milk. Once we're analyzing the Tetra Pak or the plastic pouch or the glass bottle. In those cases, the first step would be, for example, to identify the functional unit. Well, what was the need? What was the functional unit? Because it's not the same to transport, to produce, or to distribute a plastic pouch than a glass bottle. It has different functions. It depends of my truck or the distance or the user, etc., etc., etc. So once we have already identified, it's also very important to know the scope, how far I'm going to go with this life cycle assessment. It can be very, very deep and very, very complicated study, or it can be very simple. It depends on the objectives. For example, in doing a life cycle assessment, I could choose to do it from cradle to grave. In this case, we are talking about a material in Mexico called anything, which is like a fiber, come from a type of cactus. And it can be from, okay, my study will be, for example, since the plant itself is being planted, it's being cultivated, and who is going to take, for example, the knife or a machine to cut it, etc., etc. And maybe my study will be all the way until handbags are produced, for example. And the fibers are being painted, inked, and everything. Or maybe with a packaging, etc., etc. Or maybe I am the producer of this fiber and I don't produce handbags. I only produce the fiber and give it to other producers, and they can do handbags or shoes or whatever they want. And maybe then my life cycle assessment would be only until my where my reaches are in terms of only the production of the material. So in that case, for example, the scope of my life cycle assessment would be only from cradle to what it's called gate. Until the material is ready, maybe it's not even painted or inked or anything, it's just given to another supplier, and that's it. Only until the fiber is ready, maybe it's like combed, and maybe it's with a little cord there so that it's ready for another company to complete the sequence. So it depends what parts of the complete life cycle will I take. Will it be from cradle to grave? Will it be from cradle to gate? It depends, right? So for some companies, the most crucial part will be sometimes from cradle to gate, and it looks like it's very simple and it's a shorter study, but sometimes it's really deep, and it's a whole universe of from cradle to gate. It's a whole universe of data and information. Do we have to consider, for example, the tools used to cut, sometimes also the machines, if there is a local transport inside that, packaging and transport and water, etc., etc. So it's like doing in where the arrow is in raw material extraction. It's like doing a super zoom and only focusing in that part. Then it would be, we are not even going to the manufacturing part of the product itself. We are just talking about the raw material extraction. So it's like a whole universe and a super zoom just in that phase. That would be from cradle to gate. Is there any question? Yes, Shubi. Sorry.
When we say cradle, so in this area, what all we are considering how the plantation is also being done?
That's a very important question. It depends also in your objectives. Sometimes, for example, I have friends who do professionally life cycle assessments, and it depends, for example, on the client. The client sometimes would say, yes, I want to know everything, what seeds were used, how the land was watered, and if it has fertilization and fertilizers, chemicals, or maybe the client said, no, I want it to start until the plant is cut. I don't want to know if there are other things. For example, in the case of the milk, we are not really getting into the milk part, but sometimes we also could consider what the cow ate and what was the pasture and if it has fertilizers and everything, all the way from the cow when it was born almost and until it made milk, how this milk was how do you say, like extracted from the cow, and or I don't know in English, and but it depends. Depends. For example, there is another case in Mexico where there was this producer of shoes, leather shoes, and then because they wanted this European flower certification, the eco label, they had to consider everything. How the cow, what did the cow ate, and how was then later the skin and the leather produced, everything. So it depends. In the product, in the objective, it depends.
Why should it be an option?
Well,
like
yes.
Because it is a part when we are dealing with sustainable life cycle assessment. So it starts from the very point where the seed is being sown in the soil, and from where the seed is coming from the first point. So why it should be an option to consider or not consider this when
Yes.
making a product?
I think you reach a very important point in terms of sustainability. it should be part of it. It shouldn't be an option. Also, in this case, it should be considered also like the social aspects of that. Who planted the seed? Was it a kid? Was it exploitation? What? Like it should be, yes. In ethical terms, yeah, everything should be considered. Everything. But sometimes, for example, if it's for your thesis project, maybe you would take 5 years to do your life cycle assessment if you have to do all that study. But if it's for a certification, maybe yeah, you should. And it depends on the certification. If it's an environmental certification or a sustainable certification, then you should consider also social and economic aspects of that, for example. And that happens a lot, for example, in biofuels. The environmental aspects, sometimes it looks beautiful, the picture of biofuels production. But when we take into consideration that there are kids, 8-year-old kids, 10-year-old kids, working in the sugar cane production of biofuels, it's like, yeah, well, what's happening here? 8-year-old kids are working and it's not a voluntary work. Should we consider? Yeah, well, from an ethical part or point of view, yes, we should consider all of these aspects. That's why sustainability can get very complex. Another question or comment? No? Okay, so we move on to the next part. So again, reviewing the steps to do this life cycle assessment. Once your objectives and scope of the study are settled, then the inventory analysis comes, the yellow part, and this can be very tricky. As you are with this example, the milk example seeing, it can be very complicated to get some information. Sometimes until you work in these plants, you can get most of the information. Sometimes from the designer point of view or external point of view, you don't know how many kilograms. So it's difficult to measure for some things. Even if you work inside, sometimes it's difficult to get that information. So it depends again on the objectives and scope of the study. It depends why are you going to do this assessment, for what, and all that. And depending on that, you move on into the inventory analysis, and then you evaluate the impact, and a very important part, how do you interpret the results. So, and because of that, there are many different ways and tools to do this. So we have different categories of life cycle assessment. We have, for example, the super official complete method, which is life cycle assessment. This is like the most official one. There are even norms about it, standards. ISO, you know ISO? International Standard Organization. They have complete standards, a lot of standards on how you should do it, what you shouldn't be doing, how you can implement that in your organization, how do you communicate it, etc., etc. There are standards of how you should do these life cycle assessments, for example. It aims into having data precision. It's not, sometimes, for example, in this exercise, you would say like, well, I think the label for the glass bottle of the milk, well, I think it's printed maybe in this type of machine, right? But when doing this kind of analysis, you have to be accurate. Exactly what process, how much material was used, what kind of ink, everything has to be like super precise, weighted, measured, etc. Because the results will be accurate. Then the results will really, really show what is the result. And normally it's a large process. It takes sometimes this analysis. There are companies even hired to do this kind of analysis. and it can take even 1 year to do a complete analysis. It depends on what. It can take a lot of time. Sometimes you need a lot of expertise and some experience using some tools, or maybe some engineering knowledge or chemistry, because you have to work with substances, measurements, etc. So then we move, there's another type of life cycle which is called Simplified Life Cycle Assessment. For example, with my students, we use this type of life cycle assessment because it's a little bit easier, practical, if we are just trying to redesign or just make a general analysis of a product to be able to decide what design is better. For example, we don't need to do a super life cycle assessment. We can use a simplified life cycle assessment approach. And for that, we also have other tools and software. And here, what happens is, like, maybe with these results you won't be able to certify your analysis. No, but it will be helpful for other things, for redesign or other things. And it's easier, it's faster, but the results are not exact. They're an approximation of the results. And we have another type of life cycle analysis that, it's not exactly life cycle assessment, but it can help you in really analyzing each phase of the life cycle in a very fast way, in a very general way. You don't need experience, it can be like very fast. For exercises with the students, it's very useful for getting designers to understand the general facts, the general processes involved, etc. But the data here, it's qualitative and it's approximate data. For example, it's like, oh yeah, it's little energy used. How little? Well, just like this, little energy. Well, if you want to have like a certification, you cannot have like, oh, just little energy. You need to have like a proof amount. How much is little? How much is a lot, etc. But here, in the checklist, it's okay to just have a general concept of it's a lot of energy or it's a little energy. It's quantitative. It's not quantitative. It's qualitative data, which is here used. So, for example, in the first one, life cycle assessment, in order to have here, for example, you end up with diagrams. This is a very simplified. Normally, in this kind of analysis, you would have like a big tree process. You would need something to help you out to calculate each of these aspects or elements, like to add them up, to connect them, etc. So for that, there are now a lot of available tools. I'm going to talk about two right now, but there are many softwares available right now. For example, one of them is the Gabi software. And Gabi software, it can be used for companies, and if they want certifications, for example, they have very heavy categories of this program, of this software, but they also have software type of this software for students, for example, which is a little bit like lighter, simpler, but it can help you doing a life cycle assessment of all stages of the product. And what kind of companies? Well, many kind of companies have used Gabi software, like chemical or also architectural companies, to have the life cycle assessment of construction materials or you can do the life cycle assessment of complete buildings also, or automotive companies, retail stores. Many companies and industries use this kind of software. And well, it says that, for example, there are some, in the type of student type of this software, you don't need prior life cycle assessment knowledge required. I think you do need a little bit, but you can also learn while using this software. It's not, it has like a very friendly interface, and it's the user interface is very good. And what happens here is that you can use database already existent in the software, and depending on the scope of the objective of your study, you can also build up your own database, like using your local information, or you can use previous one, but then the results will be approximately. It won't be exact, because you would need to have very contextual information to do it precise and exactly. So you end up with things like this, like diagrams. This is a process diagram of how, for example, you have water, detergent, energy use. So for example, this is for a detergent soap company and how it's been used. So this is a very thick line. It means that most of the impacts come here in this part of the process. And here you can use energy, water, etc. So you can model this kind of processes, or even you can model scenarios. What if my detergent is used with a washing machine or without a washing machine? And then you can do diagrams about that. You can use existent database of different soaps, different energy resources, etc., and then you can come up with final results. For example, this is another software. This is very popular, called CIMAPRO, and I think you have it also here, right, in Guwahati. And it depends also in the type of software. You have like for engineers, or also for students. It depends on for what you're going to use it. So it has also different levels, but sometimes you need like some practice, some expertise, some knowledge to use this software. It can be sometimes a little bit confusing, and it depends on the database. If you are using local database or database from Netherlands, well, will it be useful for my study? It depends, right? And for example, I found out that in 2017, last year, this software was created, and it's an open LCA platform, which I think is wonderful, because the richness of this is that all projects, all databases created can be shared. So I don't have to start from scratch. Now, if somebody worked on glass bottles from India, then I can have already existing material here that I can use later and again, share again, and we can construct life cycles from existing life cycle, which are like open for everybody. I think this is a really rich platform to look at. It's very valuable. And well, that was about LCA. This is the complete or the official method of life cycle assessment. Now we move on to simplified life cycle assessment. You also consider all phases of the life cycle. You need to have information about each one of the phases of the life cycle, what materials, inputs, outputs, etc. But this is made, for example, in this case, this software is called Sustainable Minds. You can go online. You don't need to download anything into your computer. It's an online software, and it's the final user, or the principal final user, is for designers. So this software is thought for designers to be used. Also, marketing people, etc., or engineers can use it, of course. But it's mostly thought for designers, so that the information at the end, the results, can be useful for designers, which is normally difficult for industrial designers. If I use CIMAPRO or this kind of software, for example, and I'm a designer, it will be kind of hard sometimes. Okay, I have this result. And now, from the design point of view, what do I do now? It's sometimes difficult to take design decisions when you end up with results like, okay, you have 3.4 dioxide, sulfur, nitrogen, or some kind of results like that. Okay, in terms of design, what do I do with that? So sometimes it's difficult to translate it, and that's why this kind of software, it's useful to have like at the end, like decisions at the design level. So how do it works? You go online, you go to this online platform, you register. There is a trial. Well, this is important because it's part of the homework. Once you are registered, you have a 15-day trial. You can use it for free just to test the program, the software. And you can, and this is the real cool part, is that you can start, if you have a render or a project, for example, in AutoCAD, you can export from AutoCAD your materials, the bill of materials, directly into this software. So at the end of your render, you finish the render of your, for example, in this case, it's a toaster. You design this in AutoCAD or in Rhinoceros or SolidWorks or whatever software you used, and then export the materials, and the software will give you a list of all materials used. For example, I checked that in your render you used aluminum of this thickness because you render it with this radius, etc., etc. So at the end you have already in this program all the materials you used, and then you can go inside the database and just select, okay, I have I don't know, aluminum, and the process used is roll and then extrusion, and then so you are just trying to select, or by checklist, in each phase of the life cycle you start by selecting processes, manufacturing processes, distribution processes. You can select from the type of transport, for example. You have different trucks, different, I don't know, all this in all the different stages of the life cycle. And at the end, for example, you can have, okay, I designed two types of toasters. One is from aluminum and it's circular or whatever, and I have another one, and at the end you can have a comparison of both designs. And then you can have, from the design point of view, you can take decisions. Okay, what happens if I reduce the thickness of the material, or instead of aluminum, I use recycled copper or whatever, and then you can have like you can take easily choices, like, okay, so this environmental impact changes if I change the size, etc., etc. So the decisions now are taken from the design point of view, and you can like have a quick look of which one has what kind of impacts, environmental impacts, in what kind of stages of the life cycle, and what kind of impacts, right? And then we move to the most basic type of life cycle assessment, which is not really life cycle assessment, but it helps in visualizing during the life cycle, cycle, what impacts can be related in each stage of this life cycle. And these are called checklists. And these are very useful, for example, for design exercises with students, or just to make a quick considerations, etc., along the life cycle. And for example, we have these, they are very quick. This is the eco-design checklist, and it's like a list, and it goes by stage. Like, for example, raw material, and then they move into transport, and then distribution, then manufacturing, etc. And there are just questions. Oh, have you considered this type of material? Where does your truck come from, or whatever? And then you start like answering each one of these questions, and at the end you can have an idea of what you can change in your design. It's just, you won't have exact results, no? And they will be qualitative, but they can give you an idea of what to change in your design. This is one. And for example, in the Lens platform, this is like a commercial. This is another tool very useful for doing also that to consider the life cycle of a product. And I don't know if somebody is going to talk about this tool later in the probably.
Yeah, not in relation to the checklist, but to
Okay.
the idea generation table.
Oh, perfect. Well, so okay.
We will show something about it.
Perfect. That will be great. But as an introduction, you can find this when the Indian platform is done, it's ready, and you can find tools like this one, which can give you a very useful general direction of how to make life cycle considerations. For example, this is the SDO tool. You can register here like the general concept of your design, the project, what are the unit satisfaction unit or the needs unit, etc. And then you move into, it has several like tabs and categories. This is in the environmental aspect part, but you also have in this tool the economical consideration and social considerations. But in the environmental considerations, you have, for example, this could be more or less like the different phases of the life cycle, and it has some considerations. You can make notes here, for example, if you are designing a furniture, for example, and then you have some questions or some tips to consider in each phase of the life cycle. And then at the end, you can have a diagram which tells you if it improved or it's more or less the same impact, etc. You can move on. For example, this is another stage, and other type of questions are generated so that you can consider them in your design. So, how do we put all these life cycle assessment into the design process? So it has to do with what Ranjani was asking, I think. Yes. For example, if you have from the traditional point of view, normally you won't reach an SPSS design innovation potential because you will work, for example, I'm going to do the life cycle assessment of this bottle, and then I'm just going to pass it through the life cycle assessment, and maybe I will just end up with improvements at the environmental level of this bottle, right? So I take the bottle, and then I do the life cycle assessment, evaluate the impact, make some solutions or implement some solutions, eco-design strategies, and at the end I end up with a better or a less environmental impact water bottle. But what happens if we start from the first step or at zero step on? We don't directly start with a water bottle, so we start with a question of why a water bottle? Maybe what is the real need of having this water bottle? And then you end up designing a different life cycle completely, not the water bottle. So you start and you have more potential to design a different life cycle and an SPSS design innovation. So, thank you.